All right, so we're ready to move on. We're going to be covering problems 11-5 and 11-6 in notes 32. Our example problem says what mass of oxygen is required to react with 50.3 grams of propane? And it's a continuation basically from our last reaction. So we already have our written balanced equation, which is nice. As suggested before, we always want to identify what's been given in our problems. So we have been given 50.3 grams of propane, and we want to know what we're looking for. So in this particular problem, we are looking for mass of oxygen. So this problem is a little bit different in that the information that we're given is not in moles, and the information that we're looking for is not in moles. But what we really have to remember is, one, every stoichiometry problem has to have a balanced chemical equation. And the reason is because that balanced chemical equation gives me a mole ratio between these two things that are not otherwise related. So the only way I can use this ratio is if I use, or if my units are in moles. So I like to write down what I've been given right underneath. So I will put my 50.3 grams. And for me, this tells me that I have 50.3 grams of propane. And I'm going to put a little question mark underneath here. And I know that that means I need to find how many grams of oxygen. It also helps me focus on the mole ratio that I'll be using. Like I said, we're in grams, we've got to go to moles. So we're going to start with our 50.3 grams. And we're going to use the molar mass. You have to calculate the molar mass of propane. So for every 44.09 grams, there's 1 mole. Now, this problem is breaking it up into step by step. So notice here, this is what my calculator reads, and I'm not rounding anything yet. So we're going to take that because now it's in moles. So once I'm in moles, then I can use my mole ratio. So that's my next step. Use the mole ratio to solve. So we're going to take 1.140848 moles of propane, and we're going to, looking at our balanced chemical equation, 1 mole of propane will go downstairs and 5 moles of oxygen will go upstairs. We're converting now from propane to oxygen. We're on our way to solving this problem. But again, do not round here. We are not ready for that. So, but now we're in moles of oxygen. That's good, right? Because we want something in oxygen. We're no longer in propane, but we want grams of oxygen, which means we need to use the molar mass of oxygen to go to grams. All right, so here's our moles of oxygen from the last problem. And for every 1 mole of oxygen, oh, remember, it's O2. So it's 16 times 2 or 32 grams. And now we're going to round our final answer to 182 grams of oxygen are needed. Really important for stoichiometry is really understanding what your answer means. So when you look at this, you should be able to say in a full sentence, right? If I had 50.3 grams of propane, then in order for me to react all of it, I would need 182 grams of oxygen. Okay, and of course you would box that out. Okay. Let's go on to the next problem. Let's skip through some practice problems. Oh, here we go. All right, this is very similar to the last problem, except that instead of breaking it up into smaller pieces, we're going to do it all in one step. All right, so reading the problem, how much iodine is required to react with 35 grams of aluminum metal to produce aluminum iodide? You want to think about what it is we've been given, so 35 grams of aluminum, and what it is we're looking for, how much iodine. My recommendation is to extract that information. So I've been given 35 grams of aluminum, and I am looking for, I'm going to put a little question mark underneath this, how many grams of iodine. Little note here, notice how the information that we're given is in grams, and it doesn't clarify exactly what we're looking for, so we're going to assume that if I'm given grams, that I'm looking for grams. So just know that. In terms of thinking about this, again, the only way I can use this balanced chemical equation, the only way I can use this mole ratio is if my unit is in moles. I'm not in moles, which means I've got to convert from grams to moles using the molar mass. And that's exactly where we start. We always go back to what's given. So we're going to start with our 35 grams of aluminum. I'm going to go from grams of aluminum to moles of aluminum using the molar mass. So using the periodic table, 26.98 grams of aluminum for every 1 mole of aluminum. Again, you should be able to look at this and go, okay, I'm using the molar mass to go from grams to moles. Now that I'm in moles, right, because this is canceling, right, grams of aluminum is canceling. Now I'm ready to use my mole ratio. Well, here's my mole ratio, right? I've got 2 moles of aluminum, 3 moles of iodine. So you're going to, since I have moles of aluminum upstairs, 2 moles of aluminum downstairs, 3 moles of iodine upstairs. Again, this is stoichiometry right here. One step. Remember, you can only use 1 mole ratio in a problem. So we're going to convert from moles of aluminum to moles of iodine. Again, what are we trying to get to though? We're trying to get to grams. So now we're in moles. If I stop right here, my moles of aluminum cancels, my grams of aluminum have canceled. If I stop right now, my answer's in moles of iodine. One more step. We've got to go to grams using the molar mass. Using the molar mass of iodine, there it is. And final answer is 494 grams, because our original information had 3 significant figures. 494 grams of iodine are needed. Box that baby. Oops. Box that baby out. And that's it for this section.